using the properties of determinant and without expanding, prove that. You know, first of all, you have to observe the given determinant very carefully. And what are the possibilities, or what is the property which says the value of determinant will be 0? Provided any two rows or columns are identical. Or there is one more condition. If all the elements of a particular row or column are 0, then also the value of determinant will be 0. So let's see, somehow can we make the two rows or columns identical? What if you add C1 and C2? You get x plus a, y plus b, z plus c, which is same as column 3. So here I say that we apply, first of all, because it is a question of proof, so take left hand side the determinant, say determinant equal to x, y, z are the elements of first column, a, b, c that of second column, and x plus a, y plus b, and z plus c the third column. And we have to prove it equal to 0. So now you apply here that replace C1 by C1 plus C2. Why we are doing so? You should think in advance, because that will make it x plus a, y plus b, z plus c identical with C3 and hence 0. We have to think it beforehand. So what do you get now? This will be equal to x plus a, y plus b, z plus c, and the second and third columns will remain the same. A, b, c, x plus a, y plus b, z plus c. And right out here, I can say that yes, if the value of the determinant is 0, because the first column is identical with third column, and there is a property that if any two rows or columns, the elements are identical, then the value of determinant is 0. Question 2, again, without using the properties but without expanding, we have to prove it equal to 0. Look at it carefully. A minus b, b minus c, c minus a are the elements of row 1. Now what if you add column 1, column 2 and column 3? You know, first of all you take left hand side, which you have to prove it equal to 0. What are the elements of the determinant? The elements of the first row are a minus b, b minus c, c minus a. That of second are b minus c, c minus a minus b, and the third are c minus a minus b, b minus c. If we add the elements in the first row, you know, a minus b plus b minus c plus c minus a will give you 0. To add the elements of the first row, we should say C1 to be applied, replace C1 by C1 plus C2 plus C3. So when you add all the three to C1, what do you get? You will get a minus b plus b minus c plus c minus a, and then similarly in the second row you get b minus c plus c minus a plus a minus b, and the third row c minus a plus a minus b plus b minus a. That is column 1 only, and keeping the other two columns as such. What are the other two columns? B minus c, c minus a minus b, and the elements in the third column are c minus a minus b, b minus c. But what do you find in the first column? You know, a cancels, b cancels, c, and similarly in the other two rows. So the elements of the first column will become 0, 0, 0, and of course the other two columns remain as such, b minus c, c minus a minus b, and the elements of the third column are c minus a minus b, b minus c. So obviously the value of determinant is 0, and that's what we have to prove. Why? Because as all the elements of C1 are 0. So if we start expanding with respect to column 1, so it will be 0 times 0 times 0 times. That's why the value of determinant will be 0. We can say it without expanding. Now third sum. We have to prove it equal to 0. What is the given determinant? The elements of the first column are 2, 3, 5, that of the second is 7, 8, 9, and third is 65, 75, and 86. We have to prove it equal to 0 without expanding, just using the properties. You know, the only way out is that somehow if you could make any two rows or columns identical. Naturally, column 1 and column 2 are not identical. So somehow we have to add or subtract a multiples of either column 1 or column 2 in such a way that reduced to it will become equal to one of the columns. So here I find that what if we can try one, say what is 9 times 7? 9 times 7 is 63. 63 subtracted from 65 will leave you 2. Similarly, 9 times 8 is 72. 75 minus 72 will be 3. And 9 9 are 81. 85 minus 81 will make it 5. So then C1 and C3 will become identical. So what do we apply? The instruction is replace C3 by C3 minus 9 times C2. You know the property that if to any particular row or column, here to column 3, you subtract or add, we can say we add minus 9 times C2. It does not matter. So the value of determinant remains the same. I can continue to say yes, delta equal to. So keeping column 1 and 2 as such, 2, 3, 5, 7, 8, 9 as such, 65 minus what? 9 times the element of column 2. So minus 9 into 7. Similarly, 75 minus 9 into 8 and 86 minus 9 into 9. So what do you get? You get the first two columns, 2, 3, 5, 7, 8, 9 as such. And here you get 65 minus 63, 75 minus 72, and 86 minus 81. So in the next step you get 2, 3, 5 are the elements of column 1, 7, 8, 9 that of second. And what are the elements of third column? 65 minus 63, 2, 75 minus 72, 3, and 86 minus 81 is 5. And now we got the value of determinant 0. Why? I can say it is 0 as the elements of column 1 and column 3 are 2, 3, 5 each. That means they are identical. So using the property that if any two rows or columns of a determinant are identical, then the value is 0. So yes, we have proved. Question 4. Again, using the properties and without expanding, prove that the determinant is 0. So let me take the determinant or the left hand side 1, 1, 1, B, C, C, A, B, and A times B plus C, B times C plus A, and C times A plus B. By now you must have understood that what is the trick involved, that somehow you could make two columns or rows identical or proportional. The value will be 0. Look at it carefully. What are the elements of third column? AB plus AC, BC plus CA, CA plus AB. And what if you add the elements of second column to it? Then all the three will become AB plus BC plus CA, AB plus BC plus CA, AB plus BC plus CA. In the first column it becomes 1, 1, 1. So will be proportional. So here I propose that we should apply that change C3 as C3 plus C2. That means to elements of column 3 add the corresponding elements of column 1 and the value of delta remains unchanged. Keeping the first two columns 1, 1, 1, BC, CA, AB as such and add the elements of column 2 to column 3. You get AB plus AC plus BC. Then you get BC, I am opening the bracket, BC plus BA plus CA, and in the third element is CA plus AB plus CA plus BC and plus AB to be added. In any case, instead AB if you have BA, never mind, because after all ABC are real numbers. and the multiplication of real numbers is commutative. Do you find that all the three elements in the column 3 are AB plus BC plus CA? So either I can say the elements of third column are proportional to 1, or it doesn't matter. Let me take AB plus BC plus CA common from column 1 to get the delta equal to AB plus BC plus CA common, and you get 1, 1, 1. The elements of the second column are BC, CA and AB, and because we have taken AB plus BC plus CA common, even the elements of third column become 1, 1, 1. So you get AB plus BC plus CA, and the value of determinant is 0. Why? As the elements of column 1 are identical with column 3, and hence the result, the value of given determinant becomes 0. Now this is a very important question. It looks to be complicated, but once you get the required trick, then easily it can be done. What are you to prove? And without expanding, that the B plus C, Q plus R, Y plus Z are the elements of first row and so on, equal to 2 times, and let's see columns carefully, A, B, C, P, Q, R, X, Y, Z. Concentrate on columns. Now, look at the elements of the first column. You know, here, if you add row 1 and row 3, what will happen to the element A11? You will get A plus B, A plus C plus 2B. A plus, if you add R1 plus R2, okay, add R1 plus R2, what do you get? A plus B plus 2C. And this A plus B extra you subtract from column, from row 3, so only 2C will be left. So just see, if you replace on the left side, of course, you may write it again, take the left hand side. What is the determinant on the left hand side? B plus C, Q plus R, Y plus Z. Then you have C plus A plus B, R plus P, P plus Q, Z plus X, X plus Y. Now in this, you apply that replace R1 by R1 plus R2 and minus R3. What will happen? I am directly doing it. When you add R1 and R2, what will happen here? You will get B plus C plus C plus A. So you will get A plus B plus 2C. You will get A plus B plus 2C. And we are subtracting the elements of third row, so minus A plus B. So what will happen? This A plus B will cancel and you will simply left with 2C. Similarly, you add the elements, you know this, A1, 2 and A2, 2. So what do you get here? If you add these two, you will get plus 2R and this P plus Q will be cancelled. So you will left with 2Q. 2R, sorry, not 2Q, you will left with, yes, you get Q plus P cancelled and you left with 2R. And similarly, the third element of the first row will be 2Z. In keeping the rest two rows same, that is C plus A, R plus P and Z plus X, and the elements of the third row A plus B, P plus Q, X plus Y. What do you do now? Take 2 common from R1. Taking 2 common from R1 means from each element of R1. And you get the elements of the first row are simply C, R, Z, and of course the other two as such, C plus A plus B, R plus P, P plus Q, Z plus X, and X plus Y. Now it is simple. You know, if from the elements of row 2 you subtract that of row 1, you will left with APX. So now we'll do replace R2 by R2 minus R1. That is, subtract the elements of row 1 from row 2. you get 2 times CRZ, the elements of first row as such. Now the C plus A minus C will make it A. R plus P minus R gives you P. Z plus X minus Z here gives you C. Z plus X minus Z makes it X. So the elements of second row becomes APX, and the third row A plus B, P plus Q, and X plus Y you keep as such. And now what do you observe? That in the third row the elements are A plus B, P plus Q, X plus Y. If you subtract the elements of second row from it, and then you will get B, Q, Y, single element each. So now you apply, that is change R3 to R3 minus R2. What do you get? The first 2 rows you keep as such, CRZ and APX, and now A plus B minus A, R3 minus R2. So A plus B minus A gives you B, and P plus Q minus P gives you Q, and X plus Y minus X gives you Y. Now look at the required result. You have in the first row APX. We have APX, but in the second row. Then you need BQY. Yes, we have BQY, but that is in the third row, and CRZ in the first row. So we have got the required result. It is only a matter of rearranging the rows. Do you know a property that if we interchange any 2 rows or columns, then it changes the sign. That means we can do it with a negative sign. And you need this column APX, these 3 terms you need in row 1. So first we apply R1 and R2 to be interchanged. What do you get? Take the elements APX in row 1 and the CRZ in row 2, and keeping BQY in the third row. And because we have changed R1 and R2, so it will be negative. Still, you don't need this CRZ in second row, but the third row. So now you interchange second row and third row. So again, applying R2 and R3 to be interchanged, it will again be negative times, so negative and negative will make it positive. Now already you have APX in the first row. Now this BQY from third row will come to the second row, BQY, and the second row will come to the third, that is you will get in the third row CRZ. And you look at the right hand side carefully, so that is your right hand side. If I read it column wise, A, B, C, P, Q, R, X, Y, Z, and that's what is your right hand side. And in the process, we forget one thing to carry forward. Please give the back page. Yeah. Yes. We had taken it 2 common. Everywhere 2 common. Yes. Yes. So this 2 common is there. It is very much there. 2 minus 2 here, and minus plus this 2 is here. So even in the right hand side, the required result we had 2 times. So maybe sometimes during the process of doing the questions you miss something. So you should always revise and look at the right hand side very carefully. We can make the corrections.